Okay, so we're just going to combine now permutations and combinations with probability. So on the diploma, okay, you're going to have your set theory questions. You're going to have some gaming questions first, like puzzle solvings first. Then you're going to have the set theory questions, like intersection and union, Venn diagrams. Then you're going to have some permutation and combination. No, I'm lying. I think it goes probability questions next, then permutation and combinations, then they combine permutation, combinations, and probability, I think is how it goes. Those are your first 3 units, okay? So you have to read the questions very carefully because, again, you have to decide, is this a probability question or is this just a permutation combination question, okay? So probability. So it's the number of favorable over the total number. So number of favorable outcomes over total number of outcomes. So it's everything that you want to have happen over everything that could happen. Okay. Fundamental counting principle. We use these for arrangement questions. Okay. And all you do is you multiply, right, the blanks. Just make sure you do the restriction first. So permutations, these are the arrangements. Or another way to think of it as is that your order matters, right? So if I have Scrabble tiles, right, and I'm rearranging the letters of the Scrabble tiles, I get out a different quote unquote word each time. Now, for permutations, we can do these questions with the blanks. We can do NPR. We have the identical objects. And we have the together questions. Okay. So this should kind of start going through your brain like, oh, yes, I remember. I don't like this. Okay. And then combinations are stupid simple. These are, whoops, I've just gone and done that now. Combination questions are selections where the order doesn't matter. And there's only one way to do these is NCR. Okay. So it's the permutations that are nasty. So what's going to happen here? When we bring all this stuff together for probability, okay, the number on the top, this is going to be what the question is asking of you, okay? Or in other words, the restrictions. The denominator, watch the chord, will be no restrictions. So it's everything that you want to have happen over everything that could happen. So essentially what a permutation question, what a probability question does when you combine it with perms and coms, it's a 2-for-1 deal. So if you go back and look in your workbook, it would say you've got 6 Scrabble tiles and you want to arrange 3 of them. So that would be 6P3, right? Or 654 using the blanks method, right? That would be part A. And part B of the question would be, you've got 6 Scrabble tiles, you want to arrange 3 of them, but the first letter has to be a vowel, right? So part A, part B, you start putting restrictions in. Well, all it's going to be is the no restrictions will be that 6P3. That will be the bottom of every single one. Putting a vowel first, that's the question. That's the restriction. So essentially it's taking that restriction answer and the no restriction answer and dividing them. So it's a 2-for-1 deal. So remember what I've said, the diploma is 32 questions. We have clearly done more than 32 questions in this course. So wherever they can double dip on a concept, they will do that. So for them, it makes sense to combine perms and coms with probability because they can get a double dip for it. That doesn't mean every question is going to be a perm and com with a probability, but they are common. What's wrong? 32 with 2 long answers, so 34. It is, which means each question they're going to make sure every question, not that every question is big, but they actually, when we have our list of curriculum outcomes, they will make sure that that diploma hits about 90% of them, right? So yeah. And it might not hit it like, okay, so when we did the odds and probability, like when we did the odds lesson, we did a basic odds question all the way to the horse race question, right? We went from easy to hard. So when I say it hits a curricular outcome, I mean you're going to have an odds question on the diploma. I just don't know what level it's going to be at. But if they give you a hard odds question, they might give you a super easy probability question, right? Because they have to balance it out as the diploma goes on. Okay. Okay, so let's have a look-see. So we're not going to get this done today. We're going to take all day tomorrow and all day Thursday. Okay, and then whatever time we have left, Friday is study day, and then we'll do the exam on the Monday. Okay, and we'll just kind of take our time just making our way through this. Okay. Okay, so it says 2 cards are picked without replacement. Okay, you're going to pick 2 cards and hold on. So again, do you know what that means? It means you're going to take the first card, you're going to lay it on the table, you're not going to put it back in the deck. Okay? Determine the probability of both cards are kings. Okay? So it doesn't matter how you do this question. You can do it exactly like what we've always been doing. So both cards are kings. So the first is a king and the second is a king. Okay? So what's the chances of the first card being a king? How many kings are in the deck? 4 out of how many? 52. Okay, what does and mean? Times. Okay, now remember, you didn't put the first king back. So how many kings do you now have left to pick from? Out of how many? Okay, that will give you out a perfectly good answer. And there is no problem doing the question that way. Here's the other option. If you pull a king of hearts and a king of spades, does it matter? Does the order matter? Because you could take those 2 cards and move them in your hand, right? Move them back and forth. So this, whoops, is a select question. It's an NCR. So select 2 kings. How many kings do you have in your deck? 4, and you want 2 of them. Over total select of 2 cards. How many cards are there in the deck? And you want how many of them? 2. Believe it or not, that answer will be the same as the other answer. And if you're going, well, which way should I know? The one that makes sense in that wonderful little brain of yours. That is the way you should know. Okay? But honestly, it doesn't matter. Now, I don't remember seeing this on your diploma. No, I don't remember seeing it on your diploma. It was always just a number answer. Okay? And it's really whatever occurs to you. So all these questions, you can do them by perms and coms. There's some that have to be done that way, but I'll show you here in a sec. But it's just what, as you're reading the question, just do whatever occurs to you. They both work. Okay. The word counted is spelled using Scrabble tiles. Okay, as soon as you see that, whoops, You should be thinking in your head, arrangement. Arrangements mean permutations, right? Because you're going to rearrange those letters of the word counted. 2 tiles are randomly chosen one at a time and placed in the order in which they were chosen. So here, the order matters. Okay, so let me just show you a thing here. In the last unit, whoops, not last number, oh my. In the last unit, the question would say, determine the number of ways you can have the tiles spell CO. That's how it worded in the last unit. Determine the number of ways you can have the tiles spell CO. Okay. Well, how many C's do you have? How many O's do you have? 1. So how many ways can it spell CO? 1. That was the answer. Now, your question is saying, oh, I just did it again. Determine the probability that it spells CO. So, how many ways can you spell CO? 1. Now, the denominator is the total number of ways. So, how many tiles are you selecting? Or arranging, sorry. How many tiles are you arranging? 2. How many choices do you have for your first tile? Nope, 7. Because it's what you want over everything that could possibly happen. And then how many choices do you have for the next tile? 6. So it's 1 over 42. Or another way you could think of it as, you've got 7 tiles, you're arranging 2 of them. So it's what you want, CO, over everything that could possibly happen. Or in other words, no restrictions. It's what you want over no restrictions. No restrictions is just selecting 2 tiles from 7. 7 times 6. What if they're both vowels? Whoop. So, vowel, vowel. How many vowels do you have to pick from? 3. So you got 3 choices for the first vowel. How many choices do you have for the next vowel? 2. Over 7 times 6. Anything. So it's 6 over 42. Which reduces down to 1 over 7. Okay. So if you don't like that, the probability that the first letter is a C and the second is the O. How many C's do you have? Out of how many tiles? And how many O's do you have? Out of how many tiles? Right, because you already selected the C out of it. Same answer. Probability that the first is a vowel. And the probability that the second is a vowel. How many vowels do you have? Out of how many tiles? Okay, so that one vowel is out. How many vowels do you now have left to arrange from? Out of how many? Same answer. Now, for as much as I hate probability, this makes way more sense to me than that. Strangely enough. But it's weird. I will look at a question and it's like whatever I feel like doing at that moment. It's honestly whatever, you know what it is? It's whatever I did in the question before. Like if in the question before I was doing probability of first times probability of second, and then the next question comes up and it's one of these, it won't occur to me to go back to fundamental counting principle or Blank's method. It won't occur to me. I will stay doing what I was doing before. So is this really a new concept? No. You've been doing and questions for like 3 days now, 2 days. I'm just saying you can also think of them as permutation combination questions because they're worded similar to what we did in permutations and combinations. But you can do them how we're doing now. So can you do it wrong? Well, of course, everybody can screw things up. But in terms of, I think what you're trying to ask me is there, like, could I ever do it this way when I shouldn't be doing it that way? No. It's really whatever occurs to you. Okay? Okay. So we got Jamal, Ethan, and Alberto are competing with 7 other boys. Okay. So make sure you read this properly. You've got what? 3 plus 7. So you've got Jamal, Ethan, Alberto are competing with 7 other boys. So there's a total of 10 kiddos. Okay. To be on their school's cross-country team. All the boys have an equal chance of winning. Okay. So by the way, that's fake, right? Clearly this is a math contrived situation. Determine the probability that Jamal will win first, Ethan will win second, and Alberto will win third. Okay, so think about probability, just the unit that we've been doing. So ignore the fact that this is a permutation or a combination question you don't know. How would you attack this as a probability, the quiz you just wrote? Whoop, oh, I did it again. So the probability that Jamal is first. Ethan is second and Alberto. So hold on, is it and or? It's Jamal is first and Ethan is second and Alberto is third. If I had another boy, I'd name him Alberto. Such a cool name. Okay, so these are and questions. So how many ways can Jamal win first? What's his shot? 1 in 10. What's the shot that Ethan will win second? 1 in 9, because there's already one kid that's run first. And how about Alberto winning third? 1 in 8. Now, if you want to think of this in terms of perms or comms, does the order matter? So if Jamal wins first and Ethan wins second and Alberto wins third, is that different than Jamal winning second and Alberto winning first? Yes. So order matters. So Blank's method. Jamal, Ethan, Alberto. There's only one way for Jamal to get first, for Ethan to get second, and for Alberto to get third. One way. Out of a total, how many choices do you have for first place? How many choices do you have for second place? How many choices do you have for third place? Now look. 1 over 10 times 1 over 9 times 1 over 8. I'm just slicing it differently. Okay? So again, so if you saw a bunch of perm and com questions and then they hit you with this one, you're probably going to do it like this. But if you did a bunch of probability of the ors and the ands and the odds, right? You're probably going to do it like this. Doesn't matter. It's all good. Okay. Can they force you to do it in both ways? No. No. This is not 30-1. 30-1 they could, but we don't do that here. Now read the second one. Jamal, Ethan, Alberto will place in the top 3 positions in any order. So, okay. So because it says in any order, I immediately think now that this is a combination question, right? I think of this as a in any order means the order doesn't matter. So if I did it using the last unit, I have 3 boys, and I'm going to select all 3 of them. Okay. Over, I've got 10 boys, and I want 3 of them. But the order doesn't matter. I'm just selecting. Over here, for first place, how many choices do you have for first place? How many boys do you have to pick from for first place? 3, right? So you've got 3 choices for the first place. How many choices for second place? And then how many choices for the third place? 1. So 3, 2, 1, right? Over 10 P3. It's still going to be the 10, 9, 8. Here, let me write it like this. If you had no restrictions, how many choices for first place? 10. How many choices for second place? 9. How many choices for last place? Or sorry, third place? 8. Believe it or not, that will give you out the same answer as that. And what's kind of interesting is when you do it by blanks, so essentially we are doing it by blanks. This is thinking of as a permutation. This is thinking of as a combination. They both actually give you out the right answer, as long as you use the right numbers. So in the immortal words of my mother, there are lots of ways to skin this cat. Okay? So I think where if you're getting frustrated is that you get stuck in your head because like, oh, well, I think of it like this, but it could also be this, and I don't know, maybe it's that. With this stuff, there's actually, you'll get out the same answer. So if you wrote on your page, well, if I think of it like this, if I think of it like this, if you get out the same number, you're great. If you get out different numbers, ask. Okay? Okay, so, oh, what did I just do there? There we go. Okay, I think we'll call it good here after this, and then we'll be done for the day. So city council consists of 9 men and 6 women. Okay. 3 reps are chosen at random to form an environmental subcommittee. Okay, so if you see that and you just got done the last unit, what are you automatically thinking of? Combinations, right? The NCR, right? What is the probability that exactly 3 women are chosen? Okay. So 3 females. So how many females do you have to pick from? And how many do you want? 3. Okay. Now, because it says probability, so in the last unit, it would say how many ways can exactly 3 females be chosen? So the answer was just 6, choose 3. Now it's saying what's the probability of 3 women being chosen? So this is all possibilities on the bottom. So how many people do you have to pick from? Nope, 15. And how many positions are you filling? Right. Okay, so it's now. Usually when it's a combination question, so if you don't like that, probably that the first is a female. So how many women do you have to pick from? Out of how many? 15. And probability that the second is a female. Okay, so you got the first woman selected. She's out of there. Joyce is on the committee. Joyce, I just don't know why that name came to me. I don't know. Okay, so how many women do you got left to pick from? How many women left? Out of how many? And the third? 4 out of 13. Yep. And believe it or not, this answer will be the same as that answer. Like, it's really up to you how you think of it. Okay. More men than women on the committee. So because it's all just girls here today, we can totally say that committee will suck. But more men than women. Okay, so remember, you're filling how many positions? 3. So you got 3 positions open. So what are all the different ways you could have more men than women? You could have 2 men and 1 woman. Or what else could you have? 3 men and no women. Is that the it? Yes. Okay. So if you think of this as combinations, okay, or means add, men and women, men and women. So how many ways can we select the men? 9 choose 2. And then this one would be 9 choose 3. How many ways can we select the women? 6 choose 1 and 6 choose none, which you could leave off. You don't even have to have that there. Now, my all possible stays the same every single time, which is the beauty of probability, because the denominator is just no restrictions. You got 15 people, you need 3. Now, if you want to do this with probability, you would have to do it as the first person's a male, the second person's a male, the third person's a female. And then plus the first person's a male, the second person's a male, the third person's a male. Okay, and then you would just go like that, and you would just, so male, 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 female, male, male, male. So it would be 9 out of 15, 8 out of 14, 6 out of 13, 9, 8, 7, 15, 14, 13. Whatever you want. Now, if you're like, yeah, that's way more button pushing, but have you forgotten how annoying it is to plug in NCRs, right? You're really not going to save yourself any time. Mayor Jim and 2 women are chosen. Okay, we're not going to do part D, by the way. You can cross that one out. Oh, you don't? Okay. So Mayor Jim. So we're going to assume Mayor Jim is a male, but it would tell you that on the diploma. Okay. So Jim has to be selected. There's only one way to do that. And you got to have 2 more women. So you've got 6 women to pick from. You need 2 of them. Over all the different combinations you could possibly have, 15C3 every single time. Here, it would be Jim, woman, woman. So you've got 1 Jim out of 15. You got 6 women out of 14, and then 5 women out of 13. So how you choose to think about it is entirely up to you. I'm not trying to, I don't want to influence you on this. It's actually one of the few times in this course I don't want to tell you what to do. I just want to give you options. So tomorrow what we'll do is we'll just keep going through more and more examples, okay? And then we'll see where we're at the end of day tomorrow, and we'll kind of make a call on when we want to do our review versus unit end and all that good stuff, okay?